Hello to the people I miss the most. Welcome to your Applications of Trigonometry unit. This is the last one. It seems a little scary because it says applications, and usually you think that means word problems, but don't worry too much. I think that this is a pretty fun unit, very different from something we've ever learned before, but I think you'll like it. So let's get started. We're going to start with vectors, and then we're going to move into polar coordinates for our second part of the unit. All right, part one, vectors. Graph the directed line segment from the first point to the second point. Well, I've already done this for you. It took me a little bit of time, and I didn't want to spend that time on camera doing that. But what did I do? Well, I plotted the point 0, 0, which is located right here. Okay, and then I graphed the point B, which is 2, 5, and that's right here. And notice how it's going from A to B, and so the arrow is on B because it's going in that direction. All right, next up we have point C, which is located right here, and that point C is going to point D. Now, what do you notice about these two vectors? You notice that they're going in the same exact direction. That's kind of interesting. We'll talk a little bit more about that. What do you notice about this vector? Well, it has a unit of 1, a length of 1, and so we'll talk about what that means in a second. And then this one right here, this EF, has a different direction than our AB vector, our CD vector, and our GH vector. So that's a real quick introduction to what a vector looks like. I think the main takeaway for that particular slide is that it has direction. All right, let's go into some important definitions and knowledge regarding vectors. So first of all, a vector is a directed line segment with magnitude, which is the same thing as length, and direction. Well, we already covered the direction piece, but the magnitude talks about the length of the line. So for example, if we look at this here, versus this here, which one has a greater magnitude? Well, obviously the 25-mile, you can see that that's a longer vector, that's a longer length. So length and magnitude are the same thing. In this case, the one on the right here has a magnitude or a length of 25 miles, and the one on the left has a magnitude or a length of 15 miles. We'll typically say the word magnitude instead. All right, random fact, two vectors are equal if they have the same magnitude, length, and direction. So for example, in this particular case right here, a vector of 10 and a vector of 10 as well, these are newtons. Okay, since they're the same exact length or the same magnitude, they are considered equal. And note they're also in the same direction. All right, so what's the takeaway on this? Magnitude means length. Examples of that would be things like miles, newtons. It might be things like miles per hour. We'll see some examples of that as well. And then all vectors have direction as well. These vectors are going to the east. These vectors are going up 60 degrees. Okay, these vectors are going 0 degrees, 270 degrees, 225. So we can talk about the direction in terms of north, east, south, and west. We can also talk about it in terms of degrees as well. Okay. The length of the vector is called the magnitude. We know that. I'm just repeating it. It's very important. And here's some examples. So I've stated them before. You can have a length or a magnitude of 50 miles per hour, 25 miles, 250 newtons. So here's an example when we're using miles. Here's when we're using newtons, which is just a force, right, if you think about physics. And then this one's 100 knots per hour. That's basically a velocity, if you will, or a speed. All right. The direction of the vector tells you where you're going. Examples of direction could be north, could be 48 degrees. And so we'll mainly be dealing with degrees, but sometimes we'll deal with north, east, south, and west, which actually can be converted to degrees as well. Fun fact, velocity is a vector because it gives a magnitude, a length or speed, and it gives direction. Which one of these, in this example right here, go ahead and pause the video and see if you can find the velocity vector. All right, if you said this one right here, you are correct because it gives your speed or your direction and your velocity. So we've got 10 miles per hour is our speed, and then our direction is northeast. Some more important knowledge. The component form of a vector has these little brackets here around it. And so you're going to write it as two different things. And what are those two things? Well, V1 is going to be the horizontal component, and V2 is going to be the vertical component. So let's look down here. If our vector is this, then our horizontal length, let's say it's a length of 3, and let's say this vertical component is up 4, we would actually have a vector with a horizontal component of 3 and a vertical component of 4. And the way that we would write that, if this, oopsie, silly goose on my part, I clicked the wrong button. This here, like I said, was 3, and this was 4. We would write this as the vector, and it's got that cool little symbol on top, is equal to 3, 4. So you're saying that you're going 3 units in this direction and 4 units up. So that's how we talk about a vector in terms of its horizontal and vertical components. And if you want to put down this picture as well, I think you'll like that as well. So let's go back to this particular problem and let's actually find the components. So here we're going from 0, 0, oh no. We're going from 0, 0 to 2, 5. And there's two ways to do this, really. You can kind of look at the graph and say, what's my horizontal and what's my vertical? I can actually count here that it's 2. And I can count here 1, 2, 3, 4, 5 that it's 5. So this would be an answer of 2, 5, because that's my horizontal and my vertical. But do you really want to do that each time? I certainly don't. So what I do is I say on a number line, how far, what do I need to add or subtract to get from 0 to 2? Well, to get from 0 to 2, I would have to add 2. That's why it's a positive 2. How would I get from 0 to 5? Well, I'd add 5. So that's going to be a plus 5. In this particular example, they're all going to be positive, but we are going to have some negative situations. All right, taking a look at number 2, how would I get from -1 to 1 on a number line? Well, you can kind of look at this. Here's my 0, here's my -1, here's my 1. You can see that would be 2. So it takes me 2 to get there. And I'd be going to the right, correct? So I'd be going from -1 to 1, so I'd be going right 2. How about going from 3 to 8? Yep, that would be 5. And what's interesting here is the horizontal and vertical components are exactly the same for vectors A, B, and vectors C, D, if you look over here. And we would say that those vectors are equal because their direction is the same and their magnitude is the same. All right, let's look at EF. How do we get from -2 to 3? You're right, we add 5. How do we get from -4 to -2? Okay, well, that would be going from, let me add to my little thing here, -2, -3, -4. I would still be going right. If I was going from -4 to 2, I'd be going 1, 2, just like that. All right, and even though these have the same numbers, they're a different vector because their horizontal and their vertical components are different. How do I get from 3 to 4? I add 1. How do I get from 1 to 1? Well, I add 0. I'm already there. And so, just an FYI, this here is a unit vector because it has a unit of 1. And I'm not going to talk too much about that right now, but you should know that this is actually the vector I. And like I said, we're going to go over this in another topic. Ooh, I kind of made that funky looking. So there's my I. That's equal to 1, 0. Again, don't worry about that. We're going to do a whole video on that, but just a heads up. Okay, now we need to find the length and the magnitude of each vector. And you should recognize that we can do Pythagorean theorem with this. So for example, I could go ahead and I could draw this like that, like that. I know that that was 2 and that was 5. So I'm trying to find the hypotenuse. We can call this C, this A, and this B. And we would be doing A squared plus B squared equals C squared, which is the same thing as 2 squared plus 5 squared equals C squared, which gives me 4 plus 25 equals C squared. So that gives me 29 equals C squared. Square root both sides, and we get C equals the square root of 29. Now, kind of interestingly, I've got a formula here that I've yet to mention, and you should notice that this is the exact same thing as the Pythagorean theorem, where we square A and B and then take the square root at the end. So from now on, I'm going to use this formula down below, but know that it comes from the Pythagorean theorem. So this is going to be square root of 29. That's our length, right? That's the length of that vector. That's the magnitude. Same thing. All right, so remember this one here. The second one had the same exact horizontal components. So we're going to do this again. It's going to give me, don't forget your parentheses, 2 squared plus parentheses 5 squared. And this is essentially the Pythagorean theorem. And doing that math, I get 4 plus 25 is 29. And it makes sense that I get the same answer because they had the same horizontal components. Okay, now on this next one here, we're going to have a slightly different order, right? We're going to have a 5 here and a 2 here. 5 squared is 25, plus 2 squared is going to be 4, so 25 plus 4 is 29. So this is also the square root of 29. But notice it's not the same vector. Why is this and this vector, why are they different? They have the same magnitude, the same length, but what don't they have? They don't have the same direction, so they're not equal vectors. All right. This last one here, I'm going to put in a 1 and a 0. And just remember your parentheses, because if we do end up having a negative as a horizontal or vertical component, it's going to give you the wrong answer if you don't remember your parentheses. Well, this gives me 1 squared, which is 1, plus 0 squared, which is 0, is the square root of 1, which is 1. So again, just a reminder that this is the unit vector because it has a magnitude of 1. All right, that's it for our intro to vectors. Hope you enjoyed it. Have a great day.